Hey everyone, we are going to look at graphing. Specifically today we're going to look at a distance versus a time graph. So when we look at our graph, we always want to start by kind of identifying what our x and y axis are, and then looking at what the slope of the line tells us. So on this one, our x-axis, which is our horizontal, is time, and this one is being measured in minutes. And then our y-axis is distance, and this one is being measured in meters. Remember, time and distance can be measured in a lot of different units, so you always want to check your specific graph to make sure you know what's going on there, okay? So when we calculate a slope, you may have heard it called rise over run, or change in y over change in x. So in this case, if we call it the change in y over change in x, what we end up finding is that y is the distance that we've gone in meters, and the change in x is the time that it took. So we know from our last calculations that we just did that when you take d over t, or distance divided by time, that gives you the speed. So we call this a speed graph, because it's telling us something about the speeds of whatever is being graphed. So in this case, we are graphing Mary, Kathy, and Julie and their speeds. And we can see that on the graph, there are different shapes. And those different shapes are gonna give us different information about the speed that Mary, Kathy, and Julie are moving at. So let's look at what those shapes mean. So we already said the slope is equal to the speed, that distance over time. So again, that line is going to tell us about the speed. So if it's a straight line, and it's going to be a straight line either a straight line with a positive slope. So what we're talking about is something like Mary's graph, where it goes up in a straight line, the slope stays the same the whole time. That means a constant speed, and constant means stays the same. Okay. A flat line, meaning horizontal to the x-axis, so that is going to be like this chunk here, means that there's no motion, which means that the person or the object is stopped. So maybe Julie had to stop to tie her shoes. Took her 10 minutes. That seems long. Maybe she had to stop to catch her breath. Okay? And then when we compare the two lines, so let's say we're looking at Mary versus Kathy. They're both straight, so they're both moving at a constant speed. But Mary's slope is steeper. It goes up faster. So if they're both moving for 30 minutes, that's the maximum time here on our x-axis. Kathy was able to go, if we drag her line across, 1,800 meters. But in 30 minutes, Mary was able to go 2,400 meters. So Mary had to have been moving faster because she went further in the same amount of time. So a steeper slope, a steeper line, means they're going faster, and a flatter one, like Kathy's, means that they're going slower. Okay, let's do a quick check then. So I want you to answer these 4 questions. Go ahead, pause the video. Look back at your notes if you need to. These are the kind of the 4 major things you should have taken from that first couple of minutes there. Okay, so hopefully you actually stopped it. Remember, we got to do those check-ins. We got to keep it 100, make sure we understand what we're doing. So we want to know what is the x-axis on a distance versus time graph, and that's going to be the time. So that means that the y-axis is the distance. And then the slope is distance divided by time. So that is our speed. Okay. And then a steeper slope, meaning it goes up faster instead of gradually. means that you are going faster. Okay, the line goes up faster because you're moving faster. Okay, so let's do some calculations with these graphs. So what we can do is calculate the average speed. So we're going to be using the same equation, distance over time. But when we talk about average, we're talking about over a period of time. So we're going to change our equation slightly. Instead of just distance divided by time, we're going to say change in distance over change in time. So this triangle symbol is called a delta. And in science, delta means change. Whenever I ask you to find a change, you're always going to take the final minus the initial. So if we're looking at the change in distance, we want to know, okay, what was the final distance and then what was the initial distance? Okay, so let's see how this works. We are going to calculate the average speed of the red line from 0 to 6 seconds. So we are looking for the average, and I'm going to abbreviate it AVG, speed. And that's going to be our change in distance over our change in time. So again, if we want a change, we're going to need to know a final and an initial. So we're going to do DI, which is D initial, and DF, which is D final. And we're going to do change in time too. So we need TI, which is T initial, and TF, which is T final. So this information we're going to get from the graph. So first we're going to do our distances. So if I look at my distance, it's on the y-axis. So initially for the red line, I'm starting down here. This is kind of my first spot. I'm at 0. So my distance initially is 0. When I go, it's from over to 6 seconds because we're looking from 0 to 6 seconds. So I'm going to go over to 6 and then up to my line. So that's right here. And then I'm going to go over and I'm at a distance of 4. So my final distance is 4. I'm going to do the same thing for my times. So I'm going from 0 seconds. So I'm starting at 0 to 6 seconds. So that's going to be my final time. Okay, now I'm ready to plug these values into my equation. So I'm going to take average speed. I'm going to take my change in distance, so final distance minus initial distance, over my change in time, final time minus initial time. So 4 minus 0 is 4. 6 minus 0 is 6. And then in math, we always use decimals. We don't want to really keep it in this format. So I'm going to put in my calculator 4 divided by 6. And I get 0.666666666667. So it's 0.6 repeating. So I'm going to say that it is 0.67. And then I need a unit. So my distance was in meters. My time was in seconds. So if I'm doing distance divided by time, this is meters per second. Okay, so for the first part of this, or for this red line, we were going 0.67 meters per second. And I know because the red line is just a straight line that at every point on the line, if I calculated the speed I was going, it would be the 0.67 meters per second. Okay, let's look at another example. We're going to do the same thing. We're going to calculate the average speed, but now we're looking at the black line. So we're first going to go from 0 seconds to 2 seconds. So we're going to look at this first chunk of the graph here. So our initial distance is 0, and a final distance at 2 seconds, we got all the way to 2 meters. Okay. And then we're going to do the same thing for a time. So our initial time, we're going from 0, final time is 2. And then we'll do our math. So we're going to take final minus initial over final minus initial. I'm sorry, that's seconds. So it's 2 meters per 2 seconds, which is going to be 1 meter per second. Okay. So my average speed for this first part of the graph, and I'm going to just put it right on there, is 1 meter per second. Then it says to calculate the average speed of the black line from 0. So we're starting at the same spot. But this time we're going all the way to 6 seconds. So now we're looking at the whole graph. So let's set up again. We're going to do the initial distance. We're starting at 0. And then final distance. So I'm going to go over to my 6, up to my black line. And when I go back over, I'm at a 4 meter. And then my change in time. Initially it's 0, and then I'm looking until 6 seconds. So I'm going to take 4 meters minus 0 over 6 seconds minus 0. And I get 4 meters in 6 seconds, which equals 0.67 meters per second. Oh my gosh. So in the first part, we were going 1 meter per second. And then if we look at the whole line, we're going much slower than that. So now I need to ask myself, does that make sense? Or did I do something wrong in my calculations? So when I look at the black line, I see they were going nice and fast, 1 meter per second. They're beating the red line to start. And then in the middle here, they took a break. So here they're totally stopped. And then they went fast again. So they picked that pace back up at the end. But an average is over the whole time. So it doesn't matter that you were stopped for a while. It's just looking at where did you start and where did you end, and then how long did it take you to do that. So the red line was moving the whole time and got 4 meters. And the black line was moving and then took a break and then kept moving, but still only got 4 meters. So you guys are going to be doing some practice with this. So remember, you always come back and look at your notes. Make sure that you're showing all of your work so you can see where you made mistakes. And as always, feel free to email with any types of questions that you have.